Today we're going to be talking about temperature, pressure, and volume and how they relate to one another. To review our words, temperature is discussing the average kinetic energy of particles. So we're talking about our motion. Are the particles moving fast or are the particles moving slow? Pressure is the amount of collisions with the walls of the container. And finally, volume is referring to how much space an object takes up. For example, I'm a big guy. I have a lot of volume. I take up a lot of space. Moving down here, let's look at an example. Here we have a very full, fat football. Poor drawing of one, but a football is still the same. And we have a flat football. It's the same football. There's the same amount of air particles inside of the ball. Just one is flat. All right. What we see here is a temperature drop. Many of us have seen this in real life. You're out, you're throwing the ball with your friends. Your mom calls you in for dinner. You come back out the next day and your ball is flat, laying on the ground. Well, when we was outside throwing the football, it was a hot summer day at 94 degrees Fahrenheit. When we looked at the ball in the morning, it's done cooled off to 47 degrees Fahrenheit. We had quite a large drop in temperature. Well, as we noticed, the amount of space that the ball took up during the hot summer day and the amount of space or the volume the ball took up when it's flat was different. The flat ball takes up a lot less space. So our volume also dropped. These temperature and volume are directly related, which means what happens to one thing, such as a drop in temperature, will happen to the other thing, such as a drop in volume. If we were to heat it back up, if we were to take this flat football and we waited for the sun to come out and heat it back up to another hot summer day, then the ball would also take up more space like it did before as the temperature rises. All right, let's take a look at this example down here with volume and pressure. We're going to look at this one as we think about a combustion engine. So here we have our cylinders of our engine, and we have a piston making it stroke. Here's the bottom of the stroke, and the piston goes up and down your car. Here's your top of your stroke. If we look, we'll see the volume is different between these two strokes. Here we have about 200 centimeters cubed of volume, where over here we have about 1/8 of that at 25 centimeters cubed. We have the same amount of particles in each cylinder. As the piston rises, the volume gets smaller, and it crams all those particles into a smaller space. As a result, our particles are going to bounce off or collide with the walls of its container more, causing our pressure to go up. So, as our volume got smaller, as our pistons went up on our compression stroke, and the amount of space got smaller, then the pressure, the collisions with the walls of the container, got larger. Here is what we call an inverse relationship. What happens to one thing, such as a decrease in volume, oppositely affects the other one, or inversely affects the other one, such as an increase in pressure. All right, thanks for joining us for this version of HideScience.org and gas laws. Catch us next time. I'll see you then, or I'll see you at another time.